Yeah, good morning. Good morning, everyone. And thanks for Hack VC team, especially Alex, Ed, Chichi, Ronnie, Herbie for the invite. And yeah, today my keynote, yeah, thanks for them, like basically giving like 30 minutes for my keynote. So I will share a little bit more on the sort of the space around this rollup and also what we feel for the next few years around this rollout space and also the risk-taking space. So as you can see from the title, right, today we are going to elaborate a little bit more on the next generation of rollups we call risk-take rollup. And luckily, actually in the early morning today, we already see the midnight of EigenLayer and also the EigenDA. So they are basically the foundation for the risk-take rollup I'm going to share about. Yeah, for myself, I'm YQ, founder of AltLayer. And basically for the past few years, we've been working on the scaling solutions for a long time. My background is from this academia. Like since 2012, I started to do a lot of research around consensus protocols and also various privacy technologies like ZK, homomorphic encryption. And then later I jumped into these sharding protocols. And after that, also working for 2 and 3 years on the app chain, like sort of thesis around this Cosmos and Polkadot. And then after that, back in 2021, we started AltLayer. Basically, we envision that in the future, there will be tons of thousands of rollups to power all the applications to build a very scalable Web3 world. So as you can see, right, for the past few years, we've already have a lot of rollup stacks. For some of you, you may already try these general purpose rollups like Optimism and Arbitrum. So right now you can quickly send transactions and for DeFi protocols, like probably just spend a few cents. And with all the like sort of improvement on the rollup stacks. Right now we have Optimism OP stack, Arbitrum's Orbit, Polygon CDK, and also ZK Sync, ZK stack. So we can quickly spin off these rollups within a few minutes where these providers like us. So in that case, for a lot of applications, especially the retail applications like this gaming, social, and probably some like high frequent DeFi protocols. So now we can easily spin off the rollups and ask users all the transaction to be processed on chain. So that's the biggest, improvement for the past few years. So in that case, as you can see, right, since last year, especially this year, we saw a lot of these application rollups. No longer just like a general purpose rollup, asking users to deploy contracts on it. Right now, for a lot of these games, social, DeFi, AI, DePIN, they want to deploy their own rollup and put all these transaction activities on chain. So that's why we feel like the first sort of like paradigm shift is that instead of deploying smart contracts directly on the general purpose L1, L2. For the next few years, more and more these kind of retail application, they will just spin off their new rollups instead of deploying contracts on these L1, L2s. And our expectation is that, or prediction that by the end of this year, we probably will have like over 1,000 like rollups. And for most of them, they are actually application rollups instead of like these general purpose rollup. And if we look at all the existing rollups, right, no matter it's the general purpose one or this application specific one, as we can see, right now, either for OP, Arbitrum, or even Coinbase Base, right, it's a single sequencer. And some of you may participate in this airdrop of OP and Arbitrum. We all know that it was down for a few hours. The main reason is realize there's a single point failure. There's a single sequencer. Even we can spin off multiple RPC endpoints or full nodes, but in the end, there's just one node to process all the transactions. So in that case, we can see, right, since all the existing rollup stacks is just single sequencer, we can always have the issue around single point failure. And beyond that, when we use these rollups, right, we know that they are backed by the big names like Paradigm or sometimes Coinbase, right? And so we trust the single sequencer, even sometimes they don't have fraud proof or ZK proof. However, for a lot of these upcoming application rollups, we may not really know their name since they are from different industry, either from gaming or social industry. And our crypto users, we are not familiar with them. So in that case, we don't really have that kind of trust into their rollup. For example, if they ask us to deposit a lot of ETH, right? We may really want to look at their so not just a source code or proof, but we also want to look at their brand, because in the end, these nodes are hosted by them, and it's just very centralized. Apart from that, right? As I just mentioned, since it's a single node, and if it's not permissionless, and not everyone can host a bunch of these validators to do extra verification, right? Even they have the fraud proof or ZK proof, but as you know, all the nodes controlled by them, they can always change some of the parameters and just try to trick the users. So in that case, as you can see, right, even we made a lot of improvement and progress in the rollup space and make it very straightforward for developers to spin off rollups. However, there's still some sort of very crucial issues and problems around these rollup stacks and rollup products. And how to address these issues or problems? So after around 3 years, sort of internal research and extensive discussions with the Eigen team and also a bunch of professors, we came up with a new idea called Restate Rollup. As you can see, right, basically we are leveraging EigenLayer's share security. Basically, you can stake your ETH or STs or different sort of RSTs into EigenLayer, and later we can borrow this shared security from EigenLayer to secure some of the very important components to further secure these rollups. And as the first set of features we feel very important for rollups, we propose this vital mark and the squat. And later I will just share a little bit more on these new features. Basically, will be used to enhance the existing rollup stacks. And as I just mentioned, right, we proposed this Restate rollup, and a lot of my friends and project reach out to us. They want to use these new features. And however, they have a bunch of misunderstandings on it. For example, some of them, they feel like, are you building a new rollup stack to compete against OP Stack, Arbitrum, Orbit? Actually, it's no. And some of them, they may also confuse with the offering we are providing. Some of them, they ask, when's your midnight, when you launch your dedicated L2? Actually, the Restate rollup, not just one L2, it is sort of like a framework for all the rollups. And beyond that, for all the existing rollups, I just mentioned either it's optimistic rollup or ZK rollup, the security actually derived from their proof, either fraud proof or from ZK proof. And for us, we sort of, on top of it, we make it more decentralized and more secure. And then what's this Restate rollup and what are the benefits we can provide? As you can see, right, it's fully agnostic to all the existing rollup stacks. So you don't need to change the code of OP Stack or Orbit or CDK. On top of that, we provide all the new features and to enhance the security and decentralization of these rollups. So, and as you can see, right, on top of these features, you can further build some new products and new interesting properties. One of them actually is we can also enable the fast finality on top of these new features. Okay, as a quick sort of summary about the background, as I just mentioned, right, Restate rollup is basically a new type of modular and framework to enhance the decentralization and security for the rollups, and it's fully agnostic to the existing rollup stacks. So we don't really need to change, make any intrusive sort of amendment, sort of changes on these rollup stacks. And as I just mentioned, right, as the first set of features, we provide this decentralized verification called Vital. to basically run a dedicated set of operators and validators to do the extra verification to ensure that even it's a single sequencer, but it couldn't really do anything wrong, like double spend, because there are extra checks and verification from this network. And the second one is MAC, which provides this fast finality on top of this vital. And last one is the decentralized sequencing. We all know that they're single sequencer, right? Probably in the future, for some use cases, we really want to have this decentralization of the sequencing to make sure like there's no single point failure, or we can mitigate some of these censorship issues. And for vital, and if we look at the existing sort of systems and the roles of the rollups. Right? I'm not sure like how many of you really look deep into a source code of different rollup stacks. If you look at the look into the rollup stacks, right? It's not just a single node to do all the processing of transactions and block generation. Typically, they will split the roles into multiple ones. For example, there's a sequencer to collect and sequence and generate blocks. And there are also some other roles, like for example, load balancer. Sometimes they also run the data availability committee to store the data for some time. After that, if it's fraud proof, they will also have this called batcher or proposer to send the state root hash regularly to the L1. And if it's a ZK rollup like Polygon CDK, right, they will have this prover basically to generate ZK proof for the past like sort of transactions proposed by the sequencer and post into the L1. L1 smart contract will do the verification. So as you can see, right, it's not just a single node. And if we really want to make sure the sequencer doesn't really perform bad behaviors. So in that case, like either we blindly trust the sequencer. For example, right now I believe when we use OP or Arbitrum, when we see the transaction finalized on the L2, we will treat it as finalized. Actually, it's not right because like it's just a soft confirmation on the L2, and sometimes they will roll back, and sometimes they have to wait for the confirmation from the L1 once they post the state root hash to the L1. So in that case, either we can wait for the sort of final finality, which is some transaction to be included on Ethereum, or as I just mentioned, right, we can run a dedicated like sort of a group of nodes or validators to do this extra verification to make sure the sequencer is working fine and they are producing blocks in a like honest manner. So in simplicity, right, as you can see, we basically introduced the vital, leverage EigenLayer's AVS, and run a bunch of the operators in the ecosystem. And these operators basically behave like validators or verifiers to further verify all the transactions. And if something wrong, they will propose this proof. Like right now, we work closely with RISC-0, so it will generate the proof and post to the L1 to show that, okay, something is wrong with the sequencer, let's probably slash it and or remove or replace this existing sequencer. The next thing, as I mentioned, right, when we look at this existing rollup stack, and there's so many people discussing about like how we decentralize sequencer. When we talk to a lot of these customers and products or these clients, right? If they're doing gaming or social, for most of them, they don't really want like fully decentralized sequencing network because it will introduce a lot of latency. For example, a few seconds. But for most of the gaming and the social application, as you know, right, we are using the mobile application. Our expectation for the latency is sub-second. So in that case, this decentralized sequencing may not be applicable to all the applications, but in some jurisdictions, they don't really want a single sequencer because they treat the single sequencer as a custodian service. So in that case, somehow you have to have a group of nodes to run the to run the functionality of sequencing, and basically the group of nodes won't be that big. You can just have probably 20 or 50 or some of these nodes. Just make sure you can avoid the single point failure, or sometimes you can avoid this censorship. So in that case, as you can see, right, we propose this squad for decentralized sequencing. The purpose is not to really do the shared sequencing. Like, for example, this network serves all the rollups as a sequencer network, and so in that case, we can enjoy the interoperability across different rollups. That's not the purpose, because it may introduce these very high latency. Here, the sort of the purpose is really to decentralize the sequencing system a little bit, and to make sure there's no single point failure, but at the same time, we need to ensure that the latency is still very low. For example, lower than 2 seconds, or sometimes we want to achieve this sub-second latency. As I mentioned, right, apart from these very fundamental features we proposed for RISD rollup, we are also building some interesting features on top of it. One is this mark. Basically, via mark, we can provide this fast finality. Later, I will elaborate more into it. But in simple words, right, as I just mentioned at the beginning, if we are really waiting for the final finality on L1, so in that case, we have to make sure the L2's state rule hash pushed to the L1, and that transaction is included into a block and finalized by Ethereum. But typically, that process takes over 30 minutes, because right now, you know, right, the Ethereum is having this poll system, and they have this epoch and also slots, and each slot is 12 seconds. But typically, we need at least 2 epochs around 12 minutes to finalize a block. So in that case, if we really want a very good finality on the L1, it's around 30 minutes. However, for a lot of applications like bridges or DeFi protocols and exchanges, they couldn't really provide the sort of decent services for users. And as users, let's wait for a few minutes or 10 minutes to confirm your transfer or bridge. So in that case, as I just mentioned, right, we can build this mark on top of the Vital system. So we already have a set of operators to do the verification for the sequencer. So in that case, once some of the blocks are finalized or some of the results are finalized by this decentralized verification network, right, within a few seconds, in that case, we can get the results out of it. And then via this mark interface, all the users and developers can directly provide this fast finality for different applications and the different users. The cool part is that it's not just for developers and also for users. Typically, we also provide the RPC endpoint for you. So in that case, you don't really need to trust in a single sequencer. Instead, you can have better confidence into a decentralized verification network to provide you the sort of the finalized result with more confidence. And one of these use cases for Mark, as I just mentioned, right, is really for interoperability or for bridging. So right now, if we look at the existing optimistic rollups, right, either OP-Stack or Arbitrum Orbit, the default sort of this fraud-proof challenge period is 7 days. And if you use the native bridge for it, typically we have to wait for 7 days. And for ZK rollup, right, if we are using ZK Sync, when we do a withdrawal, it takes around 24 hours. If we're using Polygon ZK EVM, it takes a shorter time, but at the same time, we have to wait for the ZK prover to generate the proof, and usually it takes a few hours. So I just mentioned, right, for a lot of bridge services, DeFi protocol, we can't wait for that long. In that case, we have to have some other ways to do this extra verification to shorten this finality time. So one way that all the DeFi, all these bridge protocol, they run the full nodes just to do the verification themselves, right? Or they can leverage the mark service I just mentioned to basically ensure all these rollups are running fine, and the marker can expose some interfaces for the bridges, and they can just access this result. For example, one transfer transaction or bridge transaction on one rollup is finalized and verified by this mark network, and then on the other rollup, they can just submit another transfer to the destination. In this case, right, this bridge and the DeFi protocol, they don't really need to run the full nodes, and they just need to sort of connect to this interface, and then they can enjoy all the security guarantee from this mark system. On top of that, right, as I mentioned, for different services, we have different requirements for security and also the performance or efficiency. Sometimes we feel like, okay, we are fine with this latency. For example, the big exchanges or some institutions, right? They want this highest security guarantee. So in that case, as I just mentioned, right, when they do the withdrawal or when they do like sort of the transfer or any transaction on the L2, they can always wait for this finalization on Ethereum. And for some of them, if they really, really want to have the best finality or security guarantee, they can wait for the end of a challenge period, 7-day challenge period, or sometimes they wait for the verification of the ZK proof for the ZK rollup. But as I mentioned, right, for a lot of like end users like us, we want something very efficient. We want something like usable. And so in that case, we probably always prefer this faster finality or shorter this kind of confirmation time. So like instead blindly believing or trusting in the single sequencer of some rollups, right? Rollups we may not know that well, and we can basically trust this mark system, a decentralized verification with faster finality layer, and the security is directly guaranteed by the eigenlayer and borrow the security from eigenlayer. And the cool thing, as I mentioned, right, apart from the functionality-wise, via this system, we can also introduce some interesting like utility for the existing tokens. For example, for our own token, you can basically do this dual staking model. For example, you can leverage this ETH or stake on Eigen, or you can also restake some of these LST and LRT. And after that, you can also stake our own token and delegate to the operator, and this operator will be running as the mark sort of system and to secure this OP and Arbitrum. This is something we already launched, and if you want to have a try, you can just check out the website. And beyond that, right, as I just mentioned, apart from this faster finality and also faster like interoperability, we can directly provide this much more secure like sort of data via these RPC endpoints. So later you can just switch your MetaMask into this network, and then you can quickly enjoy all the decentralization and the security guarantee provided by this network. Of course, once we decentralize a little bit, and we can have some MEV mitigation for it. Of course, right now, there are a bunch of projects and partners reach out to us. They want to use this system. So in that case, I just mentioned, right? Apart from all the sort of interesting features, we can also provide this extra utility for their tokens. Like it's no longer just a dual staking. We can do triple staking, stake ETH, our token, and also the project token. In that case, their stakers can also earn extra rewards from all different parties. And beyond that, as I just mentioned, right, the whole thing is compatible and agnostic to all the existing rollup stacks. So you don't need to change any like sort of a code about it. And this is the triple staking model, right? Soon we will launch the first few AVS and the mark AVS for some of our partners, and one of them is Exterior. And later you will see that you can raise the ETH and stay our token and also the project token to earn these triple rewards from all different angles. Yeah, since I still have a few minutes, I will just quickly go through some of the technical details to enable this mark system. So to achieve mark, right, we spent over 2 years on the research side. So we really propose and implement a few different modes for the mark system. So one is this a little bit not that smart way. So basically, we ask all the operators to run all the nodes, all the full nodes of the rollups. So in that case, you can quickly, you basically need to re-execute all the transactions and storing probably several terabyte data. Of course, it's very effective, but at the same time, as you can see, right, it's very difficult to decentralize it. It's very, very heavy, and sometimes due to various reasons, there's always a syncing issue. Beyond that, we are also developing some other ways to basically reduce the cost for running operators. One way that we create this optimistic mode, basically all the, we developed the stateless client. It's not like client, it's stateless client. The stateless client for OP and some other rollup stacks, and it will just basically re-verify and regenerate the MPT like sort of hashes and just to match whether the result is the same as the proposed result from the sequencer. So in that case, the node itself is very light. And beyond that, we don't really ask them to generate or do the fraud proof or challenge every time. Once there's something wrong, there will be node operator do this fraud proof and via this bisection protocol. And beyond that, right, like to reduce the challenge period, we also make it into a ZK-proof system. So in that case, if anything wrong, right, the operator can directly generate the ZK proof, and the proof can be verified on the L1. So in that case, you don't need to do this very lengthy bisection protocol via this fraud proof and across different operators. And of course, for some interesting and applications, they want a high security guarantee, right? Instead of we do this optimistic mode, they can also ask all the operators to generate proof probably for every few blocks. So in that case, they can quickly check the verification result on the L1. And since it's a ZK proof, everything ensured by mathematics. And so basically they can get all the very firm security guarantee on the L1. So I just mentioned, right, Risty Rollup is a completely new concept. We proposed together with AltLayer since last year. Actually, it's before the Christmas time. And for the past few months, we already got a lot of interest from the partners and also customers. And since basically we are building this vital mark squad to really provide this decentralization and security from all different angles for the existing rollup stacks together with AltLayer. And apart from the features and the functionalities, we also provide this dual or triple staking for all the partners. And if you are interested in working with us, providing this Risty rollup for your applications or for your project, right? Just feel free to check out these documentations and feel free to reach out to us. Yeah, thanks again, and hope you enjoy the event. Thank you.